Okay, so we're just going to do our quick review of scientific notation. I'm going to make this real quick. If you have more questions about it, please feel free to come ask your teacher. We're here to help you. So in science, we have a lot of really big and really small numbers. For example, these two numbers here are kind of awkward to work with in their standard form. So like the mass of an electron, that is like so super duper tiny that it's got all those zeros there. Number one, that number is really awkward to look at and really understand. Also, if you tried to do a calculation with it, you're probably going to mess up the number of zeros. Like, we're human, we make mistakes, that's not cool. So an equivalent value is, in scientific notation, 9.1093826 times 10 to the negative 31 kilograms. So again, these two numbers are equal. They are the same thing. We're just writing it in a more convenient way. Same thing for the mass of the Earth. It is gigantic, but we will do calculations with that in like physics next year. So rather than all those zeros, we write it in an equal way, 5.9736 times 10 to the 24th. And so it's just a more convenient way to write numbers. So we are going to review the two different ways that we will see this. So number one, the first possibility is converting numbers that are already in standard form into scientific notation. So over here, we just have a couple of examples of what this would look like. So the starting number, 213 million that I'm pointing at here, the decimal has to be understood to be out here. So the decimal is there. We are going to move it. And so the rule is that you move the decimal place until there's one non-zero to its left. And the places that you move it is the exponent value. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 times. So we move the decimal 8 places, so the 2 is in front of it. So it becomes 2.13 times 10 to the, now it got cut off, but that is just supposed to be an 8 there. So the 8 tells us that it was moved 8 times. Now, why is it a positive 8? Well, it's because of this rule right here. If the number in standard form is greater than 1, like this one, 213 million, then the value is going to have a positive exponent. If the number in scientific notation, if the number in standard form was less than 1, you're going to have a negative exponent. So if we look at our next example here, the 0.00872, the decimal is located here. We move it 3 places over to where it's after the 8, so it becomes 8.72. We moved it 3 times, so that's why the exponent is a 3, and it's negative because the original starting number, again, was less than 1. All right. So we're going to do a couple of practice problems, and then we'll go the other way where we'll start in scientific notation. All right, so starting here with this 400,003, the decimal is understood to be here after the 3. We want to move it till there's only one digit in front of it. So we're going to move it after the 4. So 1, 2, 3, 4, 5 places. Awesome. So that's going to be 4.00003 times 10 to the something. Okay, well, we moved it 5 times. And the original number, look at it, was bigger than 1, so it's positive 5. So the exponent is 10 to the 5th. All right, let's do the one right next to it, 0.00007. So move the decimal till it's after the 7. 1, 2, 3, 4, 5 places over. But this time we moved it the other way. The original number was small, so that's going to be a times 10 to the negative 5th. Okay, and after we moved the decimal over there, the number was simply 7. Before we move on and look at the other examples, I want to point out that these numbers are equal in more ways than one. Number one, they are equal in terms of the value of the number. So 0.00007 equals 7 times 10 to the negative 5th, but also sig figs. This number here has 1 sig fig, and the way we wrote it over here also has 1 sig fig. So we were able to make this number as equal as possible, and that's a big deal. All right, let me put that back. All right, Let's look at another one, the number 19,000. Now this one does not have a decimal written, so I'm going to think ahead of time that it started with 2 sig figs, the 1 and the 9, right? So I'm going to make sure my answer in the end has 2 sig figs. So I'm going to move the decimal from where it's understood to be right here, 1, 2, 3, 4 places over. So it becomes 1.9 times 10 to the 4, because we moved it 4 places over. That looks like a 9. Let me fix it. There we go. Yeah, so that is an equivalent number, and it still has 2 sig figs, so I'm good. All right, let's try another one. 4,000 or 400,000. I can't say it. 422,000. This number originally has 3 sig figs, so when we write it over here, it also needs to have 3 sig figs. So we're going to move the decimal from where it is till after the 4, because we can only have 1 digit in front of it. So 1, 2, 3, 4, 5 places over. 4.22 times 10 to the 5th. The way I have this number written right now, awesome, 3 sig figs. So we're good. It's an equal value. One more that we're going to do together, this 422,000 down here, but this one here, I want to point out, it looks like the same number, but in terms of sig figs, it's not. This one here has 6 sig figs. That decimal at the end means that every single digit counts. It just means it's a little bit more exact. So we want to keep all those exact numbers when we convert it. So we're going to write 4.22. That's only 3 sig figs. I want to keep 6. So I'm actually going to keep the zeros this time. And then it's times 10 to the 5th, because just like the previous one, we moved it 1, 2, 3, 4, 5 places over. All right, feel free to pause it if you want and try that last one, and then unpause it and we'll check your answer. All right, this last one here, the decimal got moved 1, 2, 3, 4, 5, 6, 7, 8, 9 places over to be after the 3. And it was a small number to begin with, so it's a negative exponent. 3 sig figs before, 3 sig figs after, check mark, everything's good. Okay, next up, converting numbers that are in scientific notation back into standard form. So if the exponent was positive, remember that means the original number in standard notation is big. So that means we're going to move the decimal that many places to the right to make it a big number in standard notation. If the exponent is negative, we're going to move it that many places to the left. So we're going to do 2 together, and then you can try 2 on your own. So we're going to do the first 2 over here on the left. So 3.1 times 10 to the 4. Because this is a positive exponent, we're going to move the decimal 4 times to the right. So 31000. So we moved it, if I'm going to write it big up here, 3.1, we moved the decimal 1, 2, 3, 4 times over, and we filled in the little loopies with zeros. So that became 31,000. All right, and then the one at the bottom, because it's a negative exponent, 1.0 times 10 to the negative 4, negative exponent, we're going to move the decimal to the left 4 times. So 1, 2, 3, 4. Fill in the little loopies with zeros. So 0.00010. Why did I keep the extra 0 at the end? Because it was there to begin with as a significant digit. If I look at my original number, it had 2 sig figs, 1, 2. And so the way I write my number in the end also needs to have 2 sig figs, so check mark. All right, if you want to try these other 2 on the on the right, I don't know if I said right earlier, I might have messed that up, but these 2 that we haven't done yet, feel free to pause the video, try them, and then check back with me. All right, so this one is 100 and then 0.000099. So that is how scientific notation works. The last little thing is please take note that we need to put numbers into our scientific or graphing calculator in a certain way. First up, numbers that are in scientific notation, you really need to put them in parentheses when you type them in. And then also, in order to help your calculator, instead of typing the times 10, we do this button sequence, second EE, okay? It's actually like second comma, but I sometimes say second EE. That is going to put Like if you literally, I need you to type those buttons in your calculator, whether it's on your computer or in your hand, and you're going to literally type these buttons, open parentheses, 2.3 second, comma, the negative button is at the bottom, and then 3, and then close parentheses. If you do that and hit enter, it should say 0.0023, and that's just how you know you did it. This is kind of a trust me issue. If you learn to do these in your calculator this way, you will have fewer errors as the year goes on. So if you need help with that, again, let me know. This is just one more that you can try this calculation and make sure that you are getting the right answer. All right, so that's it. I hope this was helpful. And if you have questions, come see us. Thanks for watching.